Hello, and welcome to SAP TechEd 2020. My name is David Stocker, and I'm a product manager for SAP Analytics Cloud. For this session, I am joined by Antoine Chabert, also a product manager for SAP Analytics Cloud. Hello, Antoine.
Hello, David. Glad to be with you. Hey, David, why don't you just kick off the session with Smart Wrangling?
I can do that. Okay, so with release 2020.QRC3, we introduced the Smart Wrangler into SAP Analytics Cloud. We did this to improve the data analyst data preparation workflow, and we will make it available as a standard part of modeling starting in mid-2021. But we've already made it available for data sets already as of Q3 2020. A couple of words, what is a data set? A lot of people ask this question. It's a model. It really is just a normal model. The key thing that makes a data set is it is a model that is sort of certified to work with data science friendly tools such as Smart Predict. Result sets coming from data sets don't require flattening, they don't require transformations. So you can just think of a data set as a model that's certified to work with Smart Predict. Additionally, with Q4, with 2020.QRC4, it has the additional feature of being able to do what-if analysis on the data set. And that will show in the demo in a few minutes. So what is the Smart Wrangler and why did we build it and how is it built? So we wanted to concentrate on user efficiency. We knew that our classic Wrangler really just didn't cut the mustard when it came to giving the analyst the tools that they need to deal with dirty data. So we wanted instant modeling changes. We wanted to see them right away. We wanted them to be able to see the changes that they made. We wanted quick navigation between story and data if they're using it in an embedded use case. We wanted light modeling concepts right in the Wrangler, so we don't have to have, we do use still the main modeler for the heavyweight modeling concepts, but we wanted analysts to be able to do light modeling concepts, geo-enrichment, level-based hierarchies, these sorts of things right in the Wrangler. And we wanted to make it data-centric. So we have a term, we say data first or structure first, and the Wrangler is very much a data first modeling workflow. And we wanted to make sure that data types were inferred. So those of you who had struggled in the classic Wrangler with, say, date time, those problems are no more. We have much better inferment of data types. So basically, the modeling in the new Wrangler is lightweight. So the idea is that right in the Wrangler, you can do light modeling, okay? The models that we build directly with the Wrangler are simplified for BI usage, okay? And they're also suitable for use in Smart Predict, all right? Certain modeling actions always need to be available, whether you're in the simplified version of the modeling environment or the more industrial strength version of the modeling environment. And these are things like being able to switch a dimension to a measure or change a measure back to a dimension, being able to delete objects, geo-enrichment, creating hierarchies, at least level-based hierarchies. Parent-child hierarchies and public dimensions are a different issue, and renaming. So these are the sorts of things, these lightweight, commonly used modeling concepts we wanted people to be able to do them right in the Wrangler. Transformations. Transformations make a recurring appearance. So those of you familiar with them from the classic Wrangler, they're still there. In fact, we've added to them. There is a new option all the way down at the very end, and that is filter. And what the filter capability allows you to do is not change the data foundation that you uploaded or you acquired, but rather filter it in the model. So think of it as a static filter in the model that you're creating. It's really what you're creating. So we added this capability so that you can remove things from the view without deleting it from the data. Data types. We strongly type data in the new model. This, in fact, data sets use the new universal model that will be generally available in mid-2021. Data is strongly typed. The data types are, they're inferred when you first upload the data. And for dimensions, we have date, number, integer, string, and date and time. So we have a date time object as well. And for measures, they're either integers or they're numbers, which means floating point. Our date dimensions are inferment and in generation of date dimensions is much stronger than before. I noticed as a product manager, customers were always asking me about how they could have improved date time handling in the Wrangler. And with the new Wrangler, I tried basically all of the different typical date objects that give customers trouble, and I couldn't get any of them to give me trouble. So validation of data is also much improved. One thing you'll notice is if we have data that is problematic and you upload it, or you go to, you don't fix it and you are in the runtime, when the user downloads that data or when the user views that data, the whole row will still be there. Only things that that particular cell with the problematic data will be cleared. So the row will still be there. Hierarchies, you can create level hierarchies in the Smart Wrangler, and hierarchy creation is much easier than it was before. Custom transformations. So custom transformations are a cornerstone for the new Smart Wrangler. Specifically, the ability to script data set manipulation has long been recognized by both SAP and by our customers as a critical requirement. And so we introduce a new Wrangler expression language, or WEL, and it provides a cornucopia of manipulation functions. And they let you twist your data into any sort of pretzel that you would like to. And in addition, if you're familiar with data frames from R or Python's Pandas library, you'll be happy to know that in mid-2021, we will be adding data frames capability to the Wrangler expression language. And speaking of R and Python, the reason we didn't just put R or Python in instead of adding our own language was for performance. We wanted to minimize the number of environments that we had to move data around. So currently you have the HANA environment, SAP Analytics Cloud runs on HANA. You have the HANA environment and you have the user's browser. And we only push 2,000 rows to the user's browser because we want to minimize the data transfer. And we do the meat of our processing in HANA. And WEL is very, very friendly to working with HANA. So we do this so that we can work directly in HANA and we can get the transformations done quickly and responsively so that the user feels a responsiveness rather than having to push the data out to a separate Python stack and then push the results back into our environment. We do have Python available in the more IT industrial grade data integration workflow, and we haven't ruled it out at some future date. So, but for now, we wanted to concentrate on performance. Now I'm going to demonstrate the use of what-if scenarios, the new Q4 what-if scenario that are possible with data sets on a data set that has been created using the Wrangler, brought into Smart Predict, and then the data set created by Smart Predict is now being used in a story in a what-if scenario. So, time for the demo. So to start our demo for scenario analytics, let's have a look at the data set that attendees of the hands-on workshop ANA 363 will build up, or one of the data sets that they'll build up in that workshop. It is a data containing data from the United States National Park Service with visitation statistics for the past 40 years, from 1979 to 2019. One of the parks in this data set is Zion National Park in Utah. Some of you may be familiar with Zion because it is, not the least of which is because it is very close to Las Vegas. It is within day trip distance of Las Vegas. Many visitors to Las Vegas visit Zion, and many visitors to SAP TechEd, when it was held in Las Vegas, also visited Zion either before or after the conference. So let's put ourselves in the shoes of administrators at Zion National Park in the early months of the COVID-19 pandemic. They're planning for reopening the park, and they have to figure out under what conditions and how they're going to do it. One of the things that we can do to start with is to import this data set into Smart Predict. And this can give us a rough idea of how many forecast visitors we can expect in 2020 under normal non-pandemic circumstances. So now that I have my original forecast, I can take it and I can save it into a new data set. The first thing I'm going to do in my new data set is clone my forecast column a couple of times, put a pin in that. I'll explain why in a moment. And then what I'll do is I'll take this new data set and I will import it into a story. So in this story, I'm going to try to answer a few questions. I'm going to use the new what if analysis capability on data sets that we introduced in release 2020.qrc4 to try and examine how many buses I could potentially need, or on the flip side, how many visitors I can accommodate. Before I go any further, I should point out a couple of features in this story. When you see the thresholds here, the thresholds are configured such that if the number of visitors for that particular quarter or month is higher than the available bus capacity, then we'll have a red check mark. And if it is above 70%, it'll be a yellow warning sign. And if it's below 70% of the available bus capacity, it will be a green check or a green box, as you see here. The other thing I want to point out is that when we start doing our analysis, we are using planning in the background, but we don't need a planning license. And you don't need to worry. You can use a BI license with this. The planning infrastructure is used in the background. It creates a private version, unnamed private version in the background. Again, you don't need to worry about any of the planning infrastructure if you're just using it to do a little bit of what if scenario, what if analysis for yourself. So what I have here in the inputs is I have my bus capacity. This is how many people a single bus can carry at any given time. So those of you who have visited Zion know that these are large buses. They're with a flex point in the middle, and they often can travel with standing room. So we'll presume 80 people for a fully packed bus. Of course, we're not going to be engaging in fully packed buses in a pandemic. We're going to have various levels of social distancing in place. And so what we have here is we have a with standing room, no standing room. Every other row is blocked off, and every third row is available to riders. The next thing I have here is my fleet availability. Zion's bus fleet averages about twice the forecast lifetime when the buses were purchased. So they're rather old, and it costs the National Park Service about $5 million a year to maintain the fleet. So they are maintenance intensive. So we cannot always presume that we're going to have 100% availability on our fleet. So this is a factor that could go into my calculations. And so these two combined gives us an available rider capacity, this column over here on the far right, which is if a given bus is in operation and it can make 8 trips up and down the canyon in a week or in a day, times the number of riders that it could potentially carry under different circumstances, how many riders could that bus carry in a day multiplied by 30 days for the average month. So this is my per month available bus ridership capacity. And what we see here is that under normal circumstances with fully packed buses and the bus fleet in full operation, I'm very comfortable and well above what I need actually for my visitors. So everybody can get a seat. Now what I've done here is I have these other two columns. Remember, I cloned the columns in the data set. And the reason I did this is because I'm going to take advantage of the new what if capability. And the first thing I did when I was in edit mode is I opened up all the levels on this column here. I opened up all the calendar months, drilled all the way down, and I locked all of these cells. So if you look here, go into more, and I set, unset, read only for selected cells. And what I did is I locked all of these cells and set them to be read only. And everything else is input ready. So this is not input ready because it's a calculated measure. And these two, which clones of the original forecast measure in the data set, are input ready. So Q1, let's presume that there was virtually no effect on Q1. It's not what we're interested in planning, but I do want to plan Q2. And I'm going to have two scenarios. I'm going to have a moderate scenario where my visitation drops down. I lose all my foreign tourists, but the American visitation doesn't drop off nearly as strongly because many people still want to get out and do something, and going and visiting a national park is a potentially social distancing friendly activity. So let's say in the moderate scenario, we're only going to drop our visitation by 30%. So I will enter here, minus 30%. Now, what's going on here in the background is we are actually making use, underneath the hood, we are making use of SAP Analytics Cloud's planning engine to distribute these values. So we're actually at the quarter level. I just set minus 30%. When I open up the Q1, I'll see that every month below that has also dropped by 30%. Now I'm going to say that Q3 has also dropped by 30%. In the strong scenario, we're going to presume that we've lost all of our foreign visitation and we're losing half or more of our domestic visitation. So we're going to say in this particular situation that we are down 60%. Again, the planning engine has distributed the decrease in values across the board. This is an unnamed private version, so I don't have full access to the normal planning engine capabilities in terms of managing versions. However, it's still using the planning engine for calculations in the background. Again, minus 60%. So now that we've entered our expected visitation changes in these two different scenarios, now let's play with the fleet availability. Let's presume for a moment that we have, on any given day, we have 85% availability on our fleet. So we have 6 buses out of action being worked on. And we know that we're going to have to implement social distancing. Let's try with the very extreme form of social distancing where we only have 1 in every 3 rows active. And I can see here that if I am looking at the strong scenario or the moderate scenario, I can't actually accommodate either of them. I'm still way, way, way off. Okay, let's look at my 50% capacity. And and I'm still very close to my limits at 60% fall off. So what I reckon is if I close every second row and lock it there, I can probably accommodate a park visitation, which is about half of my normal visitation. The interesting thing is this is very similar to what the administrators for Zion did in real life. They implemented a 33 person per bus reserved seat scenario, and visitation to Zion fell off in reality by about 50% compared to 2019. So it's closer to our COVID strong scenario, in which case a bus capacity of 85% availability combined with every other row being closed gives us enough capacity to handle the visitation. Thank you. So now I'm going to hand it over to Antoine, who is going to take a deeper dive into Smart Predict and predictive planning.
Thank you, David, for an excellent introduction and demonstration of smart wrangling capabilities. So now I would like to introduce our TechEd 2020 audience to predictive planning. Predictive planning is a strategic addition to SAP Analytics Cloud capabilities, and it was made available as part of our third quarterly release mid-August. In general, planners need to define what should happen in the future as part of their forecasts, what can happen in the future, whether this relates to their expense or their sales across the different line of businesses. Predictive planning supports and accelerates their forecasting activity. It predicts the most likely evolution of KPIs based on what we learned from the past. Ultimately, predictive planning is helping our planners, the planners and our SAP Analytics Cloud planning customers to take confident decisions. The success formula for predictive planning is simple. It needs historical data over the past years or months, actuals, and these actuals will be used to create the predictive forecasts. At the heart of our predictive planning experience are automated machine learning algorithms. They create the best possible predictive model to describe the most likely evolution of actuals. Finally, planners might be aware of specific business conditions, and they can bring their business acumen and their understanding, really their reading of the latest business condition when they incorporate the predictive forecast in the planning process. So in summary, automated predictive forecasts are a very powerful weapon in the hands of planners. Predictive planning amplifies and accelerates the ability to be confident when planning. Also, it's worth noting that predictive planning is completely integrated into the planner's workflow. Planners can continuously predict, plan, and visualize in SAP Analytics Cloud as part of the end-to-end planning process. Predictive planning is accurate. It provides planners the ability to self-serve trusted predictive forecasts and ultimately augments and support the human judgment. Concretely, what predictive planning does, it lets you build a time series forecasting model at large scale directly on top of your SAP Analytics Cloud planning models. In very few clicks, you can create predictive forecasts at scale. For instance, you want to forecast the expense, the evolution of expense across your different cost types and departments, and you want to include them alongside your actuals and your forecast in your versions. So that is possible with predictive planning. The trust element is very important. And sometimes we say predictive is black box. With predictive planning, we actually provide a white box predictive model. As a planner, you can fully look what's inside the box, understand these models, and you can make sense of the trends, the cycle that are detected in your predictive model. A unique value of predictive planning is the ability to create predictive forecasts across multiple business dimensions, all in one go. And going at that granular level means, again, increasing the predictive forecasting accuracy. What our customers and partners love about predictive planning is the fact that you directly use SAP Analytics Cloud planning model as a data foundation. This really strongly reduces the total cost of ownership. You don't need to build specific data foundations for the need of predictive. From your data source, from your database, whether it's SAP BW, whether it's S4, or actually any data source that you can import data from into a planning model, you can de facto augment this planning model with predictive forecasts. And you can report on top of this data in stories, again, including your actuals, your forecasts, and your predictive forecasts. So in summary, the end-to-end data integration is very straightforward, and the foundation, the data foundation, the pivot is the planning model, as illustrated in that slide. As part of the end-to-end data flows, you can also make use of the smart wrangling capabilities that David just explained. This way, you can refine your data before you bring it to your planning model. Smart wranglings brings a very agile way to massage your data, which is particularly useful when you are prototyping the end-to-end integration and you need to compensate or rework some of the specificities of your data source. So date format would be a recurring example. So with that, I would like to conclude this short introduction to predictive planning, and I hope it got your interest. We have many assets, including a very detailed guided playlist that is available to you on our SAP Analytics Cloud website when you want to dig deeper and learn more about predictive planning. And with this, I would like to show you now a demo of predictive planning in action.
The demo scenario for predictive planning starts with this story, and what we are showing in this story is actually two tables that correspond really to different points in time and different way of using predictive planning to generate the forecast. So the first table is called here 2019 predictions. It's typically what our customers and partners do when they want to use predictive planning and the predictive forecast. They would use this so-called travel back in time approach. So here we place ourselves at the end of 2018. We know the actuals or the visitation of the different US national parks for 2019. And then we want to actually deliver the predictions and then compare the actual to gain actually that trust in the fact that the predictive forecast would be efficient to predict actually what we could receive in terms of visitor. And the second table, what you see, is when we are past, let's say, that initial use of predictive planning, and then we continuously deliver predictive planning to generate the predictions ahead to support our planning process. So here, for instance, in that second table, we have the actuals up to the end of 2019, and then we want to do the predictions for the whole of 2020. So, for instance, here we see the numbers of visitors across all the different US national parks, and we can notice that the actual number of visitors that we had was a little bit more than 100 million, and that the predictions were very close to actually the overall reality of 2019. And then we see that actually the difference between the predictions and the actuals is varying depending on the different quarters. So for instance, in the story, we can, as opposed to using, let's say, the national number, we can select, for instance, the Zion National Park, and then filter specifically to that national park, and see actually what were the numbers more in detail. So here we can see the difference or the percentage difference between the actuals and the 2019 predictions was even smaller, actually 0%. And then we see differences again depending on the different quarters. So just for the purpose of the demo, I'm using a different example, which is the Sequoia National Park. And then we can conduct the same kind of analysis really at this detail level, or actually globally, or actually per the different US national park. So now I want to take a step back and explain to you how these predictions, the two types of prediction, were actually generated using the experience that we call predictive planning. So let me switch to the predictive scenario. So actually the way I'm going to do that is by using a predictive scenario. I'm using my planning model that contains my data, that contains all my information as a source. And on using this data, using a specific KPI. So here, for instance, I want to forecast the number of visit for recreation, and then I can deliver my predictions, and I can also do that across different parks. So this is what you see, for instance, in this settings for the 2020 prediction. I use my planning model as a source. It's called here the US National Park Visitation. I use my actual version. There could be different versions. In that example, I use that actual version. I use the account that I want to forecast, the recreation visit, and then I'm asking actually for 12 months in that case ahead. And then I'm using the past history or actuals of the past 5 years. So here what I'm asking, basically, take the years 2015 up to 2019, and then deliver the predictions for January up to December. So if I was to do that in the context of that travel back in time approach that I mentioned, here there is just one field that I need to change. Instead of specifying the last observation, I specified actually end of 2019 as my last date, and then deliver the prediction from January to December. So let's have a quick look to the outcomes of these two predictive models. And starting with the one that correspond to the 2020 predictions. So here I see actually all my different US national parks. I have 82 of them, and then the predictive forecasts that are generated will be generated across all of these different parks. So each of these what is called entity years is actually a mini predictive model that is tailored to the specific variation of visits for that each and every of these parks. So to better illustrate that, I'm going to click on I'm interested actually to learn more on the Grand Canyon National Park, and so I click on the Grand Canyon, and there I can see actually a very a pattern in terms of the visit what I have. Actually, of course, lower number of visits in winter, and higher number of visits actually in the months of July. And then if I want to understand more in detail what this predictive model corresponds to, I can open the box, and inside the box it will tell me actually you have this trend which is linear over time, and then you have this very, like we noticed, this very recurring pattern every year, and then you have fluctuation, which means actually the value for a given month is depends on the value of the past 10 months. So we have an equation there that predicts actually this variation. So it gives me trust, it gives me confidence to actually how the predictive model was built. And so once I'm happy with that, with all of my predictive models, so I see here my detailed forecast for January to December, and what I will do is actually push them, what is called save forecast here, to a private version. So this is the way I build the story that I just showed you, by actually having a private version to receive the 2019 predictions, and having another private version to receive the 2020 predictions. So this kind of close the loop and makes it possible to push the predictive forecast to the context of the story, where I can then report on my actual, report on my predictive forecast, and actually perform this comparison as part of my planning process. So just to continue maybe on this demo, I'm going to show you briefly the planning model, which is the data foundation in that case. And as part of this data foundation, it's nothing is really specific, I would say, to this planning model, but I have my account dimension with the different KPIs. So here we took an example by predicting actually the recreation visit, but similarly I could have used other kind of visit, like the non-recreation visit or other KPIs that would be of interest for me as part of my planning process. And so another dimension that was really important is actually the park name. So let me open that for you. And there we have a list of actually all the different US national parks and correspond to all then the predictive model that we created for each and every of these 92 US national parks. And so now I want to take again a step back, and actually as part of this end-to-end demo or workflow, I created this planning model by using a dataset as a source. So the sequence I took for the demo was actually to import the data as a dataset, to create a planning model on top of this dataset, and then use predictive planning, the predictive capabilities, and then make all of that part of my story. So I can show you actually this dataset. I could have performed lightweight wrangling operation, like for instance, creating the date, and then all my different measures, all my different dimensions that I categorized as part of the dataset, which then made the process of creation of the planning model really simple. So that is ending up this demo of predictive planning, and I would say the major takeaway is the fact that you can actually incorporate predictive forecast as part of your planning process. In this demo example, based on the different US national park names, but in your context, maybe based on your different products, based on different region where you sell your products, based on the different costs.
David and I would like to thank you for attending this session. We would also like to recommend you related SAP TechEd 2020 sessions. We also encourage you to continue your learning experience using SAP Learning Hub. I would like to give a big shout and a big thank you to my co-presenter, David Stoker, for an excellent presentation of smart wrangling capabilities. Thank you for your attention. Enjoy the rest of SAP TechEd 2020.